Okay, so this is lesson 1-5, solving equations with variables on both sides. The vocabulary for today is just identity. It's an equation that is always true, no matter what the value it substituted for the variable is. We are going to use that word in a little bit. The steps for today are as follows. If there are parentheses, you're going to distribute. If there's not parentheses, you're going to skip the first step and you're going to move to the second step. If there are like terms, combine them, but do not cross the equal sign like we talked about, I believe, yesterday. If there are no like terms to combine on one side of the equal sign, you're going to skip that step. The third step says move the term with the variable from the right side to the left side by adding or subtracting. That means there are terms on both sides of the equal sign with variables. Number 4 is move the constant to the right side, which remember the constant is just the number, by adding or subtracting. If there is a constant on the left side, there won't always be. So if there isn't a constant on the left side, you can skip that step. And the last one is to solve for the variable using either division or multiplication. So we're going to look at A first on example 1, and we're going to look. There are no parentheses. We're going to skip. There are no like terms that we can combine, because if we combine 7k and 4k, we cross the equal sign and we can't do that. Move the term with the variable from the right side to the left side. This has a variable on the right side, so we're going to move this term from the right side to the left side. That's positive 4k, and to undo positive 4k, we have to subtract. So we subtract 4k from both sides. These cancel because they're opposites. 7k minus 4k is 3k, and that equals 15. Step 4 says move the constant to the right side by adding or subtracting. There is no constant on the left side here, so we can skip that step. And the 5th step is to solve for the variable using either division or multiplication. We knew the 3k means multiply, so we can divide each side by 3. And k equals 5. All right, and if you want to check that, you can. The next one, we're going to do the same process. No parentheses, skip. There's no terms we can combine without crossing the equal sign, skip. Move the term with the variable from the right side to the left side. There is a term with a variable right here. So we're going to move that positive 3x to the other side by subtracting it. And these can cancel. And 5x minus 3x is 2x. But I still have that negative 2 right there, so I need to remember to bring that down, equals 4. The 4th says move the constant to the right side by adding or subtracting. There is a constant on the left side to move, this negative 2. I move it to the right side by adding, because positive 2 is the opposite of negative 2. So we add 2 to both sides, those cancel. I get 2x equals 6. 2x means multiplication. The opposite of multiplication is division, so I divide by 2, and x equals 3. Okay, so these ones are from example 2 on page 41. First step, if there are parentheses, distribute. We have parentheses, so we have to multiply the 2 by the y, and then the 2 by the 6. 2 times y is 2y. Plus 2 times 6 is 12, equals 3y. Okay, then the next step says if there are like terms, combine them but do not cross the equal sign. We don't have any of those to take care of. The next one says move the variable from the right side to the left side by adding or subtracting. Minus 3y, minus 3y. These cancel, okay? 2y minus 3y is negative 1y plus 12. And actually, we can't just leave this equals, the right side of the equal sign with nothing. But 3 minus 3 is 0, so I'm going to replace that with a 0, okay? Next one, it says move the constant to the right side. We have a positive 12 on the left side. Opposite of positive 12 is negative 12. So we subtract 12 from both sides, and we get negative 1y equals negative 12. Remember yesterday we said the variable cannot be negative, and right now it is negative, so we need to divide each side by negative 1. Negative 1's cancel, and our y is going to be equal to positive 12 because a negative divided by a negative is positive. Okay, the next problem. There are parentheses again. So we got to take the 3 times the 1 and then the 3 times the 2k, negative 2k. So we get 2k minus 5 equals 3 times 1, which is 3, and then 3 times a negative 2k, which is negative 6k. Next step says combine like terms. There's no terms to combine without crossing the equal sign. Next one says move the term with the variable from the right side to the left side. This is the term with the variable on the right side. That's 6k. The opposite of negative 6k is positive 6k. So we add that to both sides. These cancel because they're opposites. 2 plus 6 is 8. So we get 8k minus 5 equals 3. Then the next step says move the constant to the right side. So the constant on the left side right now is negative 5. That needs to move to the right side. The opposite of negative 5 is positive 5. So we add 5 to both sides. And we get 8k equals 8. Divide by 8 because that says it's multiplication and we got to do the opposite. And k equals 1. Okay, last one for example 2. We have probably all 5 steps in this one. So the first one is the distributive property, which we have because we have parentheses. Okay, so we have 3 minus 5b plus 2b equals negative 2. And then I'm going to take the negative 2 times 1 and get negative 2. And then the negative 2 times negative b and get positive 2b. The next step says to combine like terms. On the left side, we have negative 5b plus 2b, so we can combine those. On the right side, we have negative 2 minus 2, so we can combine those, okay? So we get 3, and then negative 5 plus 2 is negative 3, and that's a negative 3b equals negative 2 minus 2 is negative 4 plus 2b. The next step says to move the term from with the variable from the right side to the left side. The variable on the right side is positive 2b. The opposite of positive 2b is negative 2b. So we subtract 2b from both sides. So these cancel because they're opposites, and we get 3 minus 5b equals negative 4. Next step says to move the constant to the right side. So the constant on the left side right now is positive 3, so we need to move that to the right side by subtraction. These cancel, and I get negative 5b equals negative 7. Then I have to divide each side by negative 5. These cancel, and b equals 7/5, and I want it left as a fraction, not as a decimal. I know the book has an answer of 1.4. 7/5 is the same as 1.4, and that's what I want it left as 7/5. Okay, so this example says infinitely many solutions or no solution, which is where our vocabulary word comes in. An equation that is always true no matter what value is substituted for the variable. So we're going to look at this one. We follow these same steps up here. We don't have parentheses. We do have like terms though that we can combine. On the left side there's an x here, and there is a negative 6x, and then on the other side there's a positive 6 and a negative 2. So 1x minus 6x is negative 5x plus 4 equals, and then we have 6 minus 2, which is 4 minus 5x. The next step is to move the term with the variable from the right side to the left side. So that is what's going to move. The opposite of negative 5x is positive 5x. Positive 5x. These are opposites, so they cancel, but these are also opposites, so they cancel because it's negative 5x and positive 5x, and we get 4 equals 4. And when that happens, when your x's or your variables cancel out, and you get a constant equaling a constant, as long as those two numbers on either side of the equal sign are the same, it means that it has infinitely many solutions. Okay? Now we're going to look at what happens if your variables cancel out, but your numbers are not the same on either side of the equal sign, because you will run into that. So there's no parentheses. However, on that left side, we have a negative 8x and a positive 9x that we can combine. And when we combine those, we get 1x plus 6 equals negative 17 plus x. The next step is to move the variable from the right side to the left side, so that guy, and the opposite of positive x is negative x, so we subtract. These cancel, but these two too, because they're opposites, and we're left with 6 equals negative 17. That is not true, so when that is the case and those numbers are not equal to each other, there is no solution. A shortened way for no solution is that symbol. So, they equal each other like this, infinitely many. If they do not equal, we should put a little line through there that shows they do not equal. There is no solution. And actually, if you only give me this or this, I will take half a point off, because we're in algebra now, and these here are what I'm looking for. I want you to realize that 4 equals 4 has infinitely many, and 6 equals negative 17 has no solutions. Okay, so on page 43 through 46, you're going to do 23 through 31, odd, 43 through 51, odd, and then number 55, and I think I'm going to throw in, try and do, even though one of those is even, try and do 63 through 64, because those are challenge questions, so I want to see if you can do those. Check on Canvas, though, to see when it's due, or, yeah.